Hello, welcome back to a crash course in circuit theory. We are focusing on the driver subsystem. In this video, I'm going to show you how to calculate the proper values of the two resistors that will allow the microcontroller to successfully switch on the 6-volt lamp. This is the information that you need for the lamp in order to calculate the proper circuit. This is the information that you need about the collector of the transistor, as well as some information about the current into the base. Also, here are some data that gives you some information about what are the limitations for the microcontroller. This information is what you need in order to calculate the unknown values for the collector resistor and the base resistor to properly operate this driver circuit. Let's start with the collector circuit. The collector circuit load is 6 volts and the energy source is 12 volts. We mentioned before that if the energy is larger than the load required, then we need a series resistor in order to reduce that energy to the proper value for the load. In order to complete the design, we need to know what is the voltage required by the transistor when it's in saturation. From the data sheet, we see that it only needs 0.2 volts to operate, which means the other 5.8 volts will be across the collector resistor. Since we desire 50 milliamps to flow through this series circuit, the same current that comes out of the power supply or the energy source will be the same current that goes through this series network, which means 50 milliamps will be flowing through the collector resistor. Using Ohm's law, we are able to calculate the unknown value for RC. So we've completed the design for the collector circuit. Now moving on to the base circuit. The microcontroller has to successfully drive the transistor into saturation. From the data sheet, we learned that the transistor needs about 1 milliamp in order to move into saturation. Therefore, we can assume 1 milliamp of current will flow through this resistor. That's good because the microcontroller is capable of delivering 2 milliamps, which is more than enough for this design. Since the typical output voltage for the microcontroller is 3.5 volts, we can assume that will be the power supply for the base circuit, 3.5 volts. From your transistor theory, you know that the voltage from the base to the emitter is 0.7 volts. So if we do a little simple math and we take the 3.5 volts and we subtract the voltage from the base to the emitter, we will get approximately 2.8 volts. That will be the voltage that will be across this resistor. Since we know that the current through this resistor is 1 milliamp, or that is the current that we desire, then once again we can easily calculate the unknown value for RB. If you follow this procedure for your circuit, you can come up with some similar values for different types of loads. Once again, to summarize, the information that you need would be the specifications for the load component, the power supply that you intend to use as an energy source for your load, the specifications for the transistor that you select as a driver for your load. Be sure that the current requirements or the maximum current for the transistor is large enough to handle the current that's required for your load. You need the information about your microcontroller. You may either get this from the data sheet or you may have to run a few tests to see what is the typical output voltage. And finally, you need to know how much current that you need in order to put this transistor into the saturation condition. which will allow the current to flow through the collector. Following this procedure, this will allow you to calculate the unknown values for RC and RB, and you can have a successful driver circuit to operate your any load that you desire. Okay, we have finished the driver subsystem theory. The last theory that we have to cover is the input, where we connect sensors circuits to our microcontroller. And most of the time we would need some kind of signal conditioning in order to interface the sensor to the digital requirements of the microcontroller. Thank you.